edition, December 2023. Let me share my screen.
All right, looks good.
Okay. Hope everyone can see my screen. Yeah. Uh, Today I'm talking about the Informix, how we can securely store our data and securely talk with server or client. Some of the ways I am talking in today's session. uh, I'm talking about these topics today, setting up how we can set up a TLS or SSL connection in Informix in both server and a client, and how to create a key stores and what is key store. Uh, these type of things I will talk. Next is how to set up a encryption at rest or storage space encryption with some demo. Means the demo will be like how to use AWS key store to encrypt our storage spaces. And so I will talk something about this Informix storage backup encryption using our key stores. So first, I will talk about the TLS and SSL connection in Informix. Uh, Normally, TCP connections when they connect to client to servers, uh, they share the data in plain text in the wire or in network. So in middle can catch the packets and read the data. So overcome this issue, we have to use SSL or TLS connections. So and SSL provides a privacy and integrity for data communication through reliable end-to-end secure connection between 2 points over a network. In Informix, we use most of the all the connection we use SSL or TLS. Like here we mentioned JDBC or SQLJ connections and ASQLC connection with Informix and ODBC driver connections and DB access connections, enterprise replication connections, SDR connections, primary, secondary, and also we use for ER. And we use for DB utilities like DB export, DB import, DB schema, and DB load utilities. And we can also set up SSL or TLS connection for connection manager between a server in a cluster. Uh, First, to set up a TLS or SSL connections, we need a key store. So we use P12 files as a key stores. From 1410 XE4W1, Informix started using these P12 files. Before that one, we used KDB files, and this P12 is a industry standard key store files to store the certificates and private key with encrypted by encrypting it with a password. And the password we give when we create a key store. These P12 files, also known as PKCS12 files or personal information exchange files, PFX files, and it stores the certificate chain. Uh, what is certificate chain? Certificate chain, like we have a lot of levels of in the certificates. Like main topmost level is the root certificate. These root certificate authorities give the root certificates are self-signed, and these are trusted authorities like Verisign there are other GoDaddy, other authorities will have the root certificate authorities. When we get our server certificate, these server certificate are signed and verified by the this root certificate. And next level we have intermediate certificate, and intermediate certificate is a subordinate certificate that acts as a a bridge between the certificate authority and end user certificate. It's these intermediate certificates are cross-signed by the root certificate authorities, and they give authority to issue the end user certificates. And last level is the end user certificate, and we use this in the server applications to establish SSL or TLS connections. Uh, Here we can have lot of type of certificate to create SSL communication, but in this example I'm explaining how to create a self-signed certificate and how to set up a SSL connection using that. Or we can have self-signed own root CA certificates, and using that own root CA certificate we can create a uh, uh, server certificate or end user certificate. But in this example I'm talking about self-signed certificate. So we use gskit command to create the certificate or key store. So first we create the empty key store and giving stash option. So if we give no stash, it don't create a stash file. In that case, when on init process starts, we have to provide the password. And second command is to create the certificate and private key of size 4096 uh, bits, and this certificate is signed by the own private key. Here we have a lot of option to create the certificate. Here DB is a full path name where we have to create the certificate and certificate and also key store name. Normally we use Informix dir SSL directory to store the our server certificates or key stores. From there server reads the certificates. And PW here is a password for encrypting the key store. And stash option to stash the password. Here type, we can have a lot of types when we provide the when we create the key store, but here we use P12 file, so we have to give the P12 option. And next is the stash. So you here we are telling use the existing stash file. And label, this is the label to identify the uniquely identify the certificate, and maybe we can call this label as a friendly name of the certificate. By using this label we identify which certificate to use, and this label we mention in the onconfig file to use the certificate by the server. And DN is a distinguished name. uh, we can provide some details like what is the common name of the certificate, what is organization, what is organization unit, and location, state, province, country, and all the email, all these type of details we can provide with DN. And example we have, like we can provide DN like this. And just here in the example I mentioned small CN common name as Informix server 1. And after creating the key store, we have to update the SQL host file. So in the SQL host file, we have to mention onsock SSL. So if we mention onsock SSL, the connection comes to the service will use the SSL or TLS connection. And drsock SSL used for the DRDA connection, and this is onsock SSL used for the SQLE connections. And after updating the SQL host file, update the onconfig file. In the SSL key store label, this parameter we have to give the label what we discussed in the last slide, the label of the certificate. And after that, in the net type, we have to give SSL. And next, we can start the encrypt VPs to encrypt the data shared between client and server. If we don't mention this VP class for encrypt VPs, then the Informix starts one encrypt VP the first time as a SSL operation occurs. And we can also mention the TLS version 1.2 or 1.3 in TLS version parameter. If we mention only 1.3, only it's use 1. 1.3 TLS version. If we mention 1.2, 1.3, then based on the client, it will use the version 1.2 and 1.3. After setting up all this, after creating the key store and updating the SQL file and updating the onconfig file, start the server with on init. Then now server start listening on with SSL connections. Next, update the configure the client. First, we can create the client. Client we support to OpenSSL as a base and GSKit as a base, and we can create the client key stores by using OpenSSL or GSKit. Here, there are a couple of commands how we can create a client key store using OpenSSL. So to create the client key store, we need server certificate. So export the server, extract the server certificate from the server key store and transfer it to the client machine and create the uh, client key store using this command OpenSSL PKCS12 export -out client.p12. This is the client key store file name, and we have to provide the password, and we have to give the server certificate in the PEM format in a PEM file, and we have to give the label of the client server certificate, and no need to export the keys in the for the client key store. The private keys created in the server key store are the private to that server. No need to give it to those should not be shared to the client. And after that, we have to create the stash file using the utility oncase stash, and we have to give the client client key store name client.p12 and password we gave when we create the client key store. And if the client connects to multiple servers, then we have to concatenate all the server certificates into a single PEM file, and we have to create a one combined client certificate client key store by using this one. If we have a lot more than one or two, more than one certificate, then we have to give CA names multiple times. If we have two certificate, then CA name label 1 and CA name label 2 accordingly. If you have three certificate, then we have to give third one also in the order how the certificates are stored in the PEM file. And also we can create the client key stores using GSKit. In the same way, we have to extract the server certificate from the server key store and transfer it to the client machine and create a client file using GSKit commands. And in the same way as OpenSSL, if client connects to multiple server, then get all the server certificates from all the servers and concat and repeat this command to create the client certificate. Sorry, client key store. After creating the client key store, update the conssl.gfg or create the conssl.cfg file in the Informix dir etc directory. The conssl cfg file contains this SSL key store file with uh, client key store file name with full path. And if the stash file name is different, then we can give this SSL key store stash. If the stash file name same as key store file like server client.p12 and stash file name is client.sth or stl, then we don't need to provide. If the client key store name is like client.p12 and the client stash file name like some client123.sth, then we have to give the sth file also using this parameter. and after updating this conssl.cfg, and if any client connects to the server, uh, it will go through the SSL connection. That's it, how we set up the SSL connection using Informix. And next we talk about the how to set up encryption at rest in Informix. Encryption at rest or storage space encryption is used to effectively protect the data stored on disk or media. When we have sensitive information, it's not good to store the info as a plain text on the disk. So we use encryption at rest service to encrypt the data and store and before writing into the disk. Informix ER feature encrypts the data before writing to disk. And to configure ER, we have to create a key store with on-case store utility. And set up the disk encryption parameter with the key store name and the cipher to use uh, encrypt the data. Uh, so first, to set up the encryption at rest, we have to create a key store by using on key store utility. So this on key store also create a P12 file, what we discussed in the SSL setup. And this on-key store utility creates P12 file. That P12 file is encrypted by password, and all the data inside that key store is again encrypted by a private keys, and these private keys are generated when we create key store. On key store create multiple types of key stores. Like we have local key store. In this case, the master encryption key is stored in our server, and AWS. In this case, the AWS, the master encryption key stored in the AWS services, and KMIP key store. In this case, the master encryption key stored in the KMIP service, KMIP server, and in the same way Azure we can use. And the key store contains the master encryption key in case of local key store. In case of other key stores like AWS or KMIP or Azure, it stores the details to fetch the master encryption free from the AWS or KMIP or Azure, and it don't store the master encryption key inside the key store in this case. And on key store utility have the following options. File, this is a key store file name, uh, and with path we can give, otherwise the file will be created in the etc directory, Informix etc directory. And type, we have a lot of types. We can in the discussed in the last slide, we can have local type of key store or AWS ER, AWS bar. This AWS bar key store used for the uh, backup encryption purpose, and KMIP, Azure ER, and Azure bar. And -, create option to create the new key store. By default, the password is stashed and in the stash file. And if you give the no stash option, the password is not stashed in the stash file. And -pw option to create the give the password to input to the on key store. And -list option to list the contents of the key store file. -cipher, this cipher we use for the encrypting the data. We support Informix support AES 128, AES 192, and AES 256 ciphers. And Informix use ECB mode, electric block EBC mode, AES EBC, electric blockchain mode. And this credential option we can give the credentials of the how to connect to the KMIP server, Azure services or AWS services. And -, verify option to verify the key store, and -, convert the key store from one type to the another, but we support only limited key stores here to convert from one to another key store. And change password to change the password of the key store file. No stash option, we discussed, if you don't want to stash the password, if we give no, we give no stash. And to create the key store, we use OnK store as discussed, and OnK store -create -file, and this is the key store file name, and the key store file name will be created with my_keystore.p12, and stash file created with mykeystore.sh. And cipher here AES 256, and credential the mycreds.json file. This is the credential file. So here we are creating AWS key store. So credential type of AWS EAR and AWS key ID. When we get this AWS key ID and AWS key secret, we get when we create the user, and we get these two details. AWS region where our CMK ID, or where we mention the parameter our store, these two, CMK ID and SSM key location. And when we create Amazon key stores, Amazon key service, we get this ID. And when we create the parameter store to store the master encryption key, we give this storage where we have to store that master encryption key. And I will show a demo how to create this one using this credential file. So after creating the after creating the key store, we have to update the bar. It's disk encryption parameter with the key store and cipher details. Key store, we have to give the key store name created with the OnK store utility, and cipher, we have to give the what cipher we gave when we created the key store. Roll forward create DBs option. If we mention encrypt, all the DB spaces created after this one will be encrypted. If we mention decrypt, then the storage spaces created after this are not encrypted. So for our example discussed in the last week, we update this encryption parameter like this: key store is equals to my key store, and cipher is equals to AES 256. If the key store is not in the Informix etc folder or etc directory, we have to give the full path. If the storage space encryption or EAR is enabled, all the storage spaces created are by default encrypted. And if we don't want to create a encrypted key store, we can use on spaces -u option, or in case of SQL administrator API, we can use unencrypted keyword here. And we can check using oncheck -pr if the encryption at rest is enabled or not. If we run oncheck -pr, it shows the encryption at rest is enabled using cipher and the cipher algorithm here when the EAR is enabled. And in EAR, if the EAR enabled, the root DB space also encrypted. And by running oncheck -pr command, it display the if the root DB space is encrypted, then it will show the root DB space is encrypted. And we have a small demo how to create a AWS key store and how to enable EAR in the Informix server using this Amazon AWS key store. So for this one, first we have to create a AWS user. Hope everyone can see my Chrome window. So to create a user, search IAM and create a user. Go to here users and create user. Give the username. I am giving Informix EAR as a user, and don't provide any AWS management console permission here. Here we don't need that one. Just we need programmatic access for this user. After that, attach policy to this user. I'm giving for test demo purpose administrator access and create. Click on create user. So the user is created and click on the user. Scroll down. Here we have security credential and create access key. This access key used to connect to the AWS services for this user. So create an local code, and I understand the above recommendation. Click on this and next. Inform, just give some tag value Informix EAR and create access key. Then it will create a access key for our user just created. So use this to edit the our credential file. So this is a credential file we saw in the presentation. I'm updating the AWS key ID. Just we created that one. I'm copying and pasting here. And after that,
Pavan, we're just seeing a black screen. So
sorry.
Your colors are not coming through.
Oh, yes.
I can see.
It's just black and white. It's there's not colors. But we are seeing your putty window.
Yeah, but I'm not
You
seeing
can
any
see
white.
this
I'm just seeing
credential file,
black.
right?
I can see
Okay, now I got it.
it.
Okay.
All right, thank you.
Next. Update the key secret. Copy from here. Just we from there we created. Okay. And next we create uh, a key using our key management service. Just search here KMS. You will get key management service here. Here we can create a key. Just click on create key. Select the symmetric algorithm. We use symmetric AES symmetric algorithm here. And key usage, encrypt and decrypt. Single region. And I am using here Asia Pacific Mumbai AP South 1 region here. So that's why I'm updating AP South 1 in the AWS region. Click on next. Click next. Alias. Create key symmetric. Next and Informix EAR key. I'm giving name as a Informix EAR key. Click on next and give the user for the key administrator. So I'm selecting the user just we created Informix EAR. Next, then who is the key user? Just give the same name as the Informix user just we created. Next and finish. So our key is created AWS. Sorry, Informix EAR key. Now we have to create a system manager parameter store ID to store our master encryption key. So for this one, just search AWS system manager. So this is the option to create a parameter. So scroll down. This is a parameter store. Click on explore parameter store, create a parameter and give the path what we are giving in the here SSM key location. So I'm just copy pasting this one here, the location. So secure string. So I'm selecting secure string because of this. Here we store the master encryption key and that should be encrypted by Amazon key service, what we created here, the key. And select the KMS key, Informix EAR key. We created Informix EAR key. So I am selecting the same key ID here to encrypt this master encryption key. And here we have to give the master encryption key here. That master encryption key is used to derive the encryption key to encrypt the storage spaces. So for that one, I am using a 24 bytes key here, AW, and the key should be base 64 encoded. So this is the key. I hope everyone can see that key. So I'm using 1, 2, 3, 4, 5, 7, 6, 8, 9 and all ones. This is a 24 bytes key and I am encoding it with the base 64. I'm using OpenSSL base 64 command to encode this one. So I'm copying this base encoded value. I'm pasting in the value here and create parameter. So if we open that parameter, so here it's a type is secure string and the value is encrypted. So if you want to see the decrypted value, just click on show decrypt value here. It will show the decrypted value. And this is a key ID of our key we created. So we mentioned this key ID in the credential file. In this CMK ID, AWS CMK ID. So this is a key store file and SSM key location. This is the same thing, Informix keys, AES 192 key. We given that in the system parameter store here. This is the path here. So same thing I'm mentioning here. After creating this credential file, uh, run the on-kstore command. This is the on-kstore command. On-kstore create -file my AWS key and cipher I am using AES 192 and credential file as the same thing, just I edited. So to create a key store, we have to provide a password here to encrypt that. So I am giving some password like Pavan123 and Pavan123. And yes, now the key store is created inside our etc directory with my AWS key and .p12 file, and this is the stash file. And we have to give this key store value in the onConfig file. So I'm opening onConfig file server2. This is the disk encryption onConfig parameter. Here we give onKstore equals to my AWS key and cipher is the AES 192. So this is the thing I mentioned in the onConfig file. Just save the file and start the server. It encrypting the root chunk, so it takes time. Yeah. And this master encryption key we gave here, it is not used directly to encrypt the storage spaces. Using this master encryption key, Informix derives separate keys for every storage space using our internal Informix algorithm. If ER is enabled, then it will show message initializing encryption at rest structures. Yeah, our server started. Server is online. If we run on check -pr grep -I, so here uncheck -pr command will show output as encryption at rest is enabled when encryption ER is enabled, and this EAR is using AES 192 cipher algorithm. AES 192 we gave when in the onConfig parameter with the disk encryption parameter. And the root DB space is encrypted, so it's showing the message, the root DB space is encrypted. And if you don't want to encrypt this root DB space, first start the server without EAR, and then create the key store, then set the on disk encryption parameter, then start the server. Then the root DB space will not be encrypted. This is how we use the EAR with AWS. And if we create a table and insert some rows, and if we read that row we using, if we read with onstart -g dump, we can see only we can't see the raw data. The raw data is encrypted, and we can't understand what is there on the disk. If the ER is not enabled, then we can understand what is there in the table. So this is the ER. Next, in the same way, we can encrypt the backups. For that one, use the onkey-store utility, create the key store. There in case of EAR, we use AWS EAR. If we want to encrypt the backups also, we use AWS bar in onkey-store credential file. After creating the credential file, update the bar encryption configuration parameter and give the key store file in the onConfigure, and also give the cipher just like how we gave you. And after take the backup, then the backup is encrypted. Yeah, that's it. Please let me know if you have any questions.
All right, great. Really appreciate it. Give folks a few minutes to put any questions they have in chat. I mean, I'll tell you personally, the SSL is near and dear to my heart, with as much as we are helping implement it right now. So that was incredibly helpful and really informative for all types of securing systems. So give folks a moment, put anything in chat that you have questions about. All right, I am not seeing any questions right now, so I think we are good. Is your email on the next couple slides or at the beginning?
Sorry?
Is your email address on here, or just wait for folks to reach you if there's questions? If not, if folks want to relay it to myself, our contact or the contact form on WAG, we
Okay,
can
I
get.
am updating. Yeah, you can use this email ID.
Oh, fantastic! So, folks.
Pavan.gummalla@hcl.com.
Great. So, folks, either later on have questions, or you have anybody that's watching the replay and have questions, contact info there. So, again, really wanted to thank you for this. Really helpful. Hopefully, everyone got a lot out of it. And I think we are good to go. So, thank you.
Thank you.
Yes. And you get a bunch of
And
thank
start.
yous in chat. All right. Let me end the recording.